Afternoon, good evening to everyone joining our webinar today. My name is Raphael Knut, and today with me is Arnold Utra. Arnold, happy to have you on board.
Yeah, thanks, Raphael. Same here.
So the webinar is entitled Machine Learning as a Service on Microsoft Azure specifically. This is the second introductory webinar in a series of 3 webinars. So just in case that you missed the first one, in which we provided an overview over machine learning and deep learning and machine learning as a service. So we rather focused on the foundational terminology. This webinar is going to be very practical and hands-on, how to actually use those capabilities. Before we get started, a few logistics and a brief introduction. Please move to the next slide, Arnold. So this webinar is brought to you by Knut Concepts, and it's powered by T-Systems. T-Systems is the enterprise customer branch of Deutsche Telekom. Deutsche Telekom is one of the largest telecommunication companies in the world, and T-Systems is highly committed to Microsoft technologies, which is why we are presenting machine learning as a service capabilities on Microsoft Azure to you today. Next slide, please. As mentioned earlier, my name is Raphael. I'm hosting this webinar today jointly with Arnold. And our approach to this webinar series is that the best way to learn is by teaching others. That means that we are exploring those technologies, Microsoft Azure, machine learning, various machine learning services. And as we learn, we share our learnings with the audience. I'm a business guy, if you will. I have a background in marketing, and I transitioned towards data science over the last 4 or 5 years or so. And I would call myself a so-called citizen data scientist, which is more or less a business person who has acquired some foundational knowledge of machine learning and deep learning. And Arnold, maybe you want to tell a little bit about yourself before we get started?
Yeah, hi everyone. So I am basically a computer programmer by background, and I have been working 6 years as a computer programmer, and I have experience in C and C++ and Linux, purely coding background I have. So I started off thinking of transition to data science, which I was doing, and this Raphael came along and we have started building up this webinar. And this is, I would say, one of the best efforts we have put together to teach others how to use actually Microsoft Azure. There's a machine learning service, practically how to use it. Yeah, Raphael, you want to take on, or should we go ahead?
Thanks. Sure, thanks. So I'm guessing that many of our attendees today are going to have a similar background, either to Arnold or me. So you might be a business person who is interested in data science, and you want to learn how to use machine learning and deep learning technologies in the cloud, or you might also be a programmer or developer who's transitioning towards data science. So we are targeting both audiences with this webinar series. A few logistics before we get started. In case you have any questions during the webinar, feel free to ask those. Use the chat box, and we're going to collect those questions and answer them as good as we can at the end of today's webinar. And this webinar is going to be recorded, so just in case you want to review that or share it with your colleagues, you're going to get an email within the next few working days with a recording, as well as with a link to the previous webinar, just in case you want to watch this one as well. So the presentation part by Arnold is going to take approximately 45 to 50 minutes. So we are hoping that our webinar is going to last for 60 minutes. In case we go over time, it's not going to be more than 5 or 10 minutes or so. All right, so with that, let me hand over to you, Arnold. The stage is yours.
Yeah, thanks, Raphael. So today we're going to talk about as a machine learning service. And before we go on with that, I have to tell you the basic difference between these 3 services. You see Databricks, Machine Learning Studio, and Machine Learning Service. These are the 3 major services when you talk about Microsoft Azure Machine Learning, when the services they provide. So Databricks is basically a collaborative machine learning platform based on Apache Spark, and it is an in-memory data processing engine. Now, the meaning of in-memory here is generally whenever we do anything, whether on your laptop or your workstation, generally it takes the process in matter of chunks. small bits of data it takes up and processes it, and then goes to next chunk and processes. This is how the whole data is processed. Now Spark is in memory, means it will take the entire data in memory in one shot. So that's why it's 100 times faster than Hadoop, the Apache Hadoop. And second, it differentiates from other services is you use it for mostly streaming service. This is the one major difference between Databricks and all the other services that are offered. So IoT devices or any other online streaming service, actually generally they are supposed to run on Databricks as per Microsoft recommendations. Now, second is Machine Learning Studio. It is a standalone machine learning solution for citizen data scientists like Rafael himself or all the business users which do not have any science background, science or mathematics background. And that is why this is one reason Machine Learning Studio is easily consumable and automated. I have personally deployed some machine learning solutions on it. So it is very easy and straightforward. Now, when we come to machine learning service, which we are covering today, it provides tools to scale and automate training, deployment, and monitoring of machine learning models. And essentially, it brings the power of containerization to data science. Power of containerization means here actually deploying as web service. So Microsoft uses Kubernetes service for this, and this is another Microsoft service. So whenever you want to deploy all the machine learning models on the web, it's very easy to do through that. So after this basic introduction, an Azure machine learning service comes in two interfaces primarily. One is a visual interface, and this is the notebook interface. Now you can see visual interface looks more like a set of boxes. You can drag and drop them and do your data processing and machine learning modeling. But when it comes to notebook interface, it looks more like a Python code. It is built on Python language. And today we will be covering a visual interface, and in the next webinar, which is happening day after tomorrow, we will be covering notebook interface. Okay. Regarding the data set we are going to use. In this data set, we are going to predict the price of a car or any car. When other values like horsepower, number of cylinders, the length of car, the width, the fuel type it takes, etc., all these values are given. And we will predict the price of car based on the basis of these values. And this is how the sample data set actually looks like. And if we zoom into this part, you can see the curve weight here, engine type, number of cylinders, engine size, all these things are given in the data set. This is how the final actually the model looks like, the machine learning model and the visual interface. This is how it will end up. All those arrows you see, each one has a specific meaning, which we will explain step by step. So before we move ahead with the modeling, we have to get our context right. So this is basically data science processes. Any company you go, small scale, medium scale, or even a large multinational corporation, and you are building small open source solution or a solution for your business, generally goes through these 7 steps. First, you define the project, which in business term means what is the business problem that you are trying to solve through data. Once you define the business problem that you want to work on, you collect data according to that. Then we analyze the data. Then we do some statistical modeling onto it. Then we deploy the model and we monitor the model for further feedback. And these steps are not essentially occur in isolation. Sometimes we collect the data and we analyze the data and we see, okay, this is not what we needed. We needed more or we needed less. We go back and collect the data again. So they keep on happening. Same thing, maybe when you model it, then you see, oh, this is not what we're looking for exactly. So we go back and collect the data or redefine the problem. But whatever you do, these 7 steps are always the part of focus of any data science project. Before you start, we will get familiar with little bit of Azure terminology. So you see, one is a resource group and other is the resource. If we want to work through the visual interface or even the notebook interface, anything in machine learning on Azure we want to do, we have to create a resource group first. And on the top of that, we create a resource. Now, what are these? So resource is just another name for the service. This is how they use it. So as a machine learning resource will be used for Azure machine learning service. And if you are looking for data storage, then we will create a Azure data factory resource, etc. Whatever the name of the service is. A resource group is a container or collection of different resources. It is essential to create it. Without this, you cannot create a resource. Now, one thing I want to tell you here, what we are doing here, the webinar, will be mostly of screenshots rather than the live webinar. The reason is that once we create a resource group or when we are creating a resource, it takes around 15 minutes to 30 minutes to do that, to create it. And if we are doing this webinar live, it may well take some 3 to 4 hours for the whole webinar to finish. And last time I did an online webinar for myself, it took me 4.5 hours to show this. So we are using screenshots so that we don't have to wait while the things go on. So how to get started? Before you go with Microsoft Azure, you need to have an Azure account. Yeah, this is simple thing, but we want to mention it here. You see, this is azure.microsoft.com here. And on the top right corner, you see this. You create a free account first. And once you hit that link, you will come across this. You start free and you get this. You have to create a new account. You get a new email address. And this is important. It will ask you to add your phone number, your identity verification by credit card. Unless you enter your credit card details, it will not move ahead. Once you enter your credit card details, you will get a $200 credit to your account to work with any of the other service. Okay. There are some free usage also available, but you get $200 credit. This may look like a lot, but it is not much. Once you start using service, $200 may just disappear like smoke if you are not careful. So once you're done with the credit card details, you will get an option to choose a subscription. We are having currently pay-as-you-go subscription in this webinar, what you're gonna see, but you can choose other subscriptions. These are the major categories. There are other subcategories in them. But when you see 80% savings, it comes with certain conditions like 3 years advance payment you have to give. So if you want to know more, you can go to this link here I'm providing at the bottom, and you can go to this page and read about some 17 different kind of subscriptions they have. Okay, we will sign in once we get an ID. And once you sign in, you will see this portal link here. We have to click on that. And once you click, this is the Azure portal homepage. So in this webinar, whenever I'm going to talk about going back to homepage, this is the homepage we are talking about. And Azure is basically, changing constantly. So while I was creating this webinar in last 1 month, they have changed the interface twice. Not big change, I would say, some 10-20% changes here and there. But if you focus carefully, what are we trying to do? Look at the reasoning that I'm explaining, then you will be able to get through those minor obstacles, no matter what interface they change. Because behind this all interface, all these icons, all these menu choices, it lies the same technology. So you see on the left side here, this is called left pane, and all these small things you're seeing, they are called blades in Azure terminology. So I am looking at right now home blade. This is called home blade. Same way there is all resources blade you see. Then in the middle you will see your subscription information. We have pay as you go, like I mentioned earlier. Then on the right side you will see a link to technical documentation. Anytime during your machine learning modeling, you can just go to homepage and go to documentation and read more about it. It is, I would say, not easy to find the information. Sometimes you have to reread and reread and reread, but you'll get through it once you practically have done it. So what we're going to do is we're gonna click on this all resources and see where we go. Okay, this is the all resources page, and you can see right now here, currently there are no resources to display. So how do you create a resource? Now to create a resource, you have to create a resource group first. So what we do is we go to the home page, we click on the resource groups blade, and we will get this page, which looks similar to older page, but if you see carefully, it is showing currently no resource groups to display. So we will create one. And this is the page you get. And you can see here, you can enter the name and this region. This will always be central US, so you can change it to whichever the region is near to you, so that the processing and all the things happen faster. But every region has a different price. There's a minor difference in pricing. When I have given the link to subscription page in the beginning of this webinar, you can always go check in there which region actually costs you less. And this is a subscription. So we have only one, so it is automatically selected this. So at the lower left corner of the screen, you see here, we click on review and create after adding names and everything. So it will give you a validation pass check. So I have chosen the resource group October 18R. My region is West Europe. And we will just click on the create on the left corner here. Yeah, nothing has displayed. No, there is something has displayed. You look at the upper right corner top. You see this? This is where the information is going to display. Resource group is created. It took me 15 minutes of wait to see this message actually. What I'm going to say here, this bell icon you see, if you do not see anything happening on the screen after you have created something or after you have deleted something, or you hit OK or you hit cancel, whatever you have done, you go to top right corner and click on the bell icon here. This is the notification panel. So Azure is not that visual about whatever is going in the background whenever you create or delete something. So you make sure you go to this bell icon on the top right corner and check it first before you just start using it or start assuming that things are done when you hit OK or when you created or deleted something. This is one important thing you have to remember. Okay, this is the resource group blade we have selected, and you can see the name here. It has been created. And if we click on this actually here on the October 18R, and you get this page. This is the resource groups homepage. Currently, there is no resource to display because we have not created any resource yet. We created a resource group, not resource. So we will create a resource. How to do that? We'll go to home page. In the left pane, the top blade is create a resource. We click on it, and in this middle menu here, you will see this AI plus machine learning. All data science or data analysis, machine learning all come through this headache. And once you click on it, you will see it like this. And we will select this here, machine learning service workspace. Now be careful, there is also similar looking machine learning studio workspace. So you better click on the service workspace. This is a page we are going to get. And you can see it is asking to create a workspace name, your subscription, and resource group, which we have created already, and your location. Once we do all these, you can see at the bottom review plus create. We will hit on it, and we will get this page as a final check. All these you see green checks means this thing is done. All are correct. So you can see this is what we created, October 18 our resource group earlier. I'm using it. October 18 MLS is the workspace name. Now, one thing you keep in mind, I have created and deleted different resources while I was creating this webinar because I wanted it to be accurate and practical both. So for the accuracy's sake, I created and deleted resources and resource group many times, experimented a lot. So sometimes you will see the resource group or resource name is changed a little bit. Instead of October 18 hour, you will see October 24 hour or something. So that's a minor thing I wanted you to notice, so don't get confused on that. Ultimately, the steps are all same. So after we are done, we click on the create at the bottom. And like I said, it is lesser visual. So you go to the top right corner and you will see this deployment in progress. It took me half an hour to get it done. It's like that. So after maybe 2-3 minutes, you see this in the middle of your screen. Your deployment is underway. And once it is done, this is how it will look like. Now, one point here, you created one resource, but you see 4. Why is that? Because once you're doing machine learning experimentation, it will be other resources are needed in the background. So they will be used indirectly. You cannot use them directly here. This is just one point. Sometimes if you may want to create some 2-3 different models, and you may create 2-3 resources, and then you will see some 22 resources showing up here. So you have to remember the names of your resources here. So this is what we created, October 18 MLS. So this is what you're going to work with. So we will experiment with data on this. This is the home page, and I go to all resources just as usual. And you see here, I click on this, what I created. And this is that workspace homepage, the Azure Machine Learning Service workspace homepage, to be accurate. And you will see we are interested in this. There is a notebooks interface, there's a visual interface, and we'll select the visual interface, and you will see this. We will launch it. It will open up in a new tab. This window will not change. So this is how the machine learning service workspace looks like. Pretty much empty. But there are things on the left side. There's a blue pane, and you can see experiments, web services, and data sets. So machine learning, modeling, data processing, all is known as experiment in Azure terminology. So when you see experiment, it means you're doing some sort of data processing or machine learning modeling. This is just the terminology. They are one and the same thing otherwise. And you can see on the upper right corner, once you're experimenting here, it will show you the resource you're using and the region you're using, West Europe here in our case. And on this here, you will see the experiments list. We do not have anything right now. On the lower left corner, you can see the new button, which you'll use to create a new experiment. Okay, so this is the introduction to the home page of the visual interface. Now we will match this process with the data science. Why it is necessary? I just do not want to get down into technical details and then totally forget about data science process, because data science process is the backbone of this. So we will mix and match the things here: project definition, data collection, and all these processes. So project definition. Our project definition right now, the problem we are trying to solve, we are trying to create an analytics solution that predicts the price of any car using visual interface, of course. And then we will do data collection regarding that. So data set is a sample provided by Azure itself. Then we go do data preparation, which will exclude certain data or clean out missing data. And I have to tell you one thing. This is not full-fledged total 100% machine learning solution for everything for everyone, because Microsoft is still working on it. So right now there are some very basic data preparation techniques are included. Not 100% of it what Python language provides, but they are working on it, and to bring more facilities, more models, more libraries. And I think in future, not far away, maybe hardly a year, maybe this will go to 10 times in number, all this data cleaning and data preparation or the modeling techniques you are going to see right now, maybe 100 times more than that. So modeling, this is machine learning modeling part. We will train a machine learning model here. Now there are 2 types of machine learning algorithms to speak in a broader sense: classification and regression. A classification predicts from categories like color, what color of car they are going to buy, to predict that. That will be classification problem. But regression is used to predict a number, and we want to predict price, which is a number. So we will use a regression algorithm for that. Now the word algorithm and the word model, machine learning model, they are one and the same thing. Algorithm is used in the world of computer programming. That's from where I come from. But in machine learning world, we call it a model. And other basic difference is there. We create algorithms by hand when we are writing code. But when it comes to machine learning, you do not have to create anything by hand. You just use pre-built models. You can create models, but these models or these algorithms which have been there available with Azure through this interface, they have been created, edited, revised, maybe more than 1,000 times or 10,000 times by different programmers around the world. So they are highly efficient, highly effective. So even if you create an algorithm, it will not be as good as this. This is one bitter truth. And second thing, companies are finding it increasingly difficult in this all data science hype, which is going on, big data hype, to find the talent who really understands all this machine learning modeling and data processing and all these steps. Technical knowledge in actually, I mean. So it's better to use pre-built models in this case and to save a lot of time. Ultimately, the end point is how to solve the business problem. And this is where pre-built models come into the picture. Okay. Then we will evaluate the model, which is just checking and testing how well the model functions. We will have a procedure for that. We will explain. Okay, experiment or modeling or the data science process. So we have defined the project, what it is. This is the homepage of visual interface. Currently, there are no experiments. We can click on this button to get a new experiment. And once you click on that button, you will get this pop-up. And you can see they have provided this full-fledged machine learning solution. There are 5 or 6 samples they have provided. You can just click open it here and it will open the full-fledged model in front of you, but it will not explain how each step is done. It will just give you the result in a number. And if you look at that number, it will not even explain how you have done it. But in any case, if you want to use it, you can just open it and see how it is, how does it work. It doesn't explain anything. You may have to read the documentation, which I showed on the homepage, technical documentation link on the portal homepage. You have to read a lot. That one thing I have to tell you. So we are going to show you step by step. We click on the blank experiment. This is how the blank canvas, I will say, let's call it a canvas, how it looks like. You can see on the left side, this is a set of menus here. These are all a set of boxes, which I showed in the beginning, how the visual interface looks like. You just have to drag and drop them here. The data transformation, these are machine learning models. These are the saved or sample data sets they have provided. On the top, you can set up your experiment name. This you can edit. And on the right side here, this is interesting here, this thing. This will be the properties or the characteristics of the boxes that you're gonna drag from here. Okay, any box you select from here, your properties will show here. We will use the properties to do the data cleaning or modeling or everything, what you're going to do. Then at the bottom side, you can see, you can save the model if you want. In the middle, if you have some work, you can just save it and come back to it later. But you have to remember, if you are saving it, it is still running on the cloud on Microsoft Azure, and you will be charged for it, and it will not be a small amount. Okay. Yeah, data collection. So we do not need to collect any data. We already have the sample data set. So this is the, on the left side, on the samples, you can see this automobile price prediction. This is what we're going to use. And we will also change the name to automobile price prediction model. And how to drag it, I will show you an animated image. So you see this, go to save data sets here, samples, and you drag this one. Right, let us see it again once more. Okay. Go to save data sets, samples, and from there we get automobile price data. Once we drag it, all the watermarks and everything on the canvas will go. And we are going to do is, we are going to select this box using the left mouse click, single click, and you will see the properties will appear on the right side here. And you can see the size of the file, 25.8 kilobyte. It's a CSV file, comma separated values. All the values are separated by commas. You can click on this here, view dataset. It will download the dataset on your computer, and you can open in your text editor or Excel, whatever you want, and have a look at it. Like I showed in the beginning, how does it look like? Okay. Now from the same left menu, we'll go to data transformation, and we drag this down, select columns in database, this one. And you can see now there are two boxes, but this one has a red alert. Whenever you see a red alert, it means the information in the box is incomplete. You have to complete it manually. How you do that? We select the data set, single mouse click this box, and we go to the properties, and there's edit columns. We'll select it. This will pop up on your screen. So I will enlarge it here. You can see this here, the options, and I'm going to show you animated image again, what options to choose. So you see this, all columns, column names, and all features we use. Okay, you hit start again. Okay, so we see this now. Still it is red alert is there. So now we're going to see how it is changed. You see all columns, all features is there. So if you want to compare to what it was earlier, see red alert is still there. So how do we get rid of it? You see, this is what you're going to do. You're going to the top circle here and drag down our mouse pointer and connect it to the lower box. See it again. Here, yes. Once we connect it, you can see there's no red alert anymore. Now what happens, all these boxes are independent. This box holds the data here, but the lower box has the capacity to select columns. This is going to do a data processing step, but they are independent. You have to connect them. That is what the red alert was showing. This is how you have to read it. Okay. So now we will run the experiment just to see how it looks like the data set itself. We have selected all columns and all features, and we're going to visualize the data. Before you move on to modeling or anything, we'll select the run here from the bottom part, and this will pop up on your screen. Set up a compute target. Let's zoom into it. This is the option you get. Currently they will give you only one option. This compute target means you can choose number of CPUs and the RAM and the storage. So currently our data set is very small, so by default it is giving us this. We can only enter a name. We cannot edit it right now. So we'll choose a name. If you already have created earlier, you run an experiment earlier, so you can just select an existing, but we are creating it first time, so we'll choose a compute name here, and we will hit run just at the bottom here. And what has happened? Like I told you, it is not very visual. I have hit the run. I am running the experiment, but I can't see it. You have to go to the upper right corner. You see this? Queued. And small dot circle is just rotating if you do it live. This is the process of doing anything when you run an experiment. It will be queued first, then it will be showing preparing compute target, then it will be running. Took around half an hour for me. So this experiment, solid reason, that is why I said you're not showing it online. Once running is done, you can see the green check here. This box will be green. We can right click on this empty dot here, this circle here, and we click on visualize here. And this is how it looks like. Let us zoom into certain areas. So this data set has 205 rows and 26 columns, small data set. And if we pick up any of the columns, let us pick up horsepower. And you can see this here. Let's zoom into it. So you can see from the graph, majority of cars are between 48 to 120 horsepower. This is what the data gives us. So you can look at each and every column and see what that data looks like to understand it more, and what are the different features, what is given to you, and what you can predict on the basis of that. You should look at the data actually before experiment with it. That will be one advice I can give. Okay, our project definition is done. Data collection is done. We will do data preparation part. How to do that? But why are we going to clean out or include, exclude certain data? What is the reason? I'm zooming into one of the columns called normalized losses. This is one of the columns out of 26. If you look at this column, the first 10 values, 6 are missing. Now, if these many values are missing, we cannot use it to predict something. There is a saying in data science world, your predictions are as good as your data. So you better make your data accurate. When these many values are missing, we will let go of that column. This is a very, very basic process in data preparation. Now, how we'll remove this column? We'll click on this select columns box, which you have here, and we'll get the properties on right side. And I'm going to click on edit columns. Okay, so edit columns, and I will click on this include. I will convert it to exclude. There's an option, it's a drop down menu. And here on this empty box, I'm going to literally type by hand normalized hyphen losses. There is no support right now for the auto completion, so you have to type manually the name of the column. And after you hit enter, this is how the blue box it comes out to be. You have to make sure blue box is there by hitting enter or by hitting tab after you finish typing the name. Otherwise it will not work. You'll get some error during the experimentation. So I'll hit on OK. This is important. You see now this part, how it is. Normalized losses have come up here. Exclude column names. If we compare it with what we had earlier here, we had this all columns, all features, and now it is turned to all columns, but exclude column name this. Okay. Now you see certain things there. Whenever we are doing an experiment or doing this modeling or data cleaning, there's a continuous flow of information from the left side and to the right side. Right side are the properties, left side is what we drag and drop everything. This is how the whole process goes on visual interface, left to right all the time. And you can write comments also. You can double click any box and write a comment so that you can remember what does this box do, rather than checking properties all the time. So I can double click and I wrote it excluded normalized losses column, this box. So I do not have to go to properties and recheck it. Okay, now we are dragged the third box. You can see clean missing data. You find it in same data transformation. Now the different thing here is this one has 2 points. Now what does that mean? So we click on this single mouse click, we select the box and we'll go to properties. You see here, when we are cleaning missing data, we have cleaned up the columns. We have not cleaned up the rows yet. So this is what we are going to do. So we will choose a value here, remove entire row. When we have a lot of values missing from a column, we remove the column, and we have a lot of values missing from the row, we will remove the row. This is, now we go to modeling part. How do we start the modeling process? Regression, that's what we are using. So linear regression we're gonna do because we are training only on one element here, price. So we split the data in 2 sets. This is the procedure we use in modeling in regression. Training model and the test model. So train model will use 70% of the data and the test model will be 30% of the data. It is most like you're cutting your data in 70-30 ratio. And this 30% data here will be untouched whenever we are training the model. We will not touch it. We'll use it for the comparison later. So we'll split the data, and the 70% of data, what will linear regression look for? It will look for the correlations between a car's different features and its price. Like I said, it's a pre-built algorithm. It's a pre-built model. It has its own intelligence, which you do not need to worry about. It will just try to find relations on its own. And then once we get certain values, which I will explain what those values are, then we get those values and we'll match them with the rest 30% of the untouched data, so that we can make sense that whatever we have predicted is actually accurate or not, because rest 30% of the data is real, it is untouched. And sometimes 80-20 train test model is also used. That depends. Okay, so we will go to this data transformation and we'll pick up this split data box and we'll drag it here. This is how canvas looks like now. And we'll select this split data, and you can see the red alert here. What we are going to do here is 70-30%. So this value, which is 0.5, which means 50%, we will change it to 0.7, which means 70% of the test. We're gonna split 70-30. Okay, this is how it looks like. Now 4 boxes we have. But remember, red alert is still there. We'll see how we'll complete it. So we will go to machine learning part now. I'll pick up linear regression, this algorithm. We'll drag it down. This is how we have 5 boxes now. We'll drag down the train model also. Now you see here, so many dots here. You see 2 dots here, 3 dots here, 1 here, 3 dots here. How to make sense out of it? Very simple thing. You see here, we are splitting the data here, 70% and 30%. The first dot represents 70%, second dot represents their empty dot, 30% of the data. Now 70% of the data is what we are going to train. So we will connect this to the training model. Now training model, we will do what? It will run linear regression. So we'll connect linear regression to train model. Well, they are still incomplete. I will complete them. So cleaning out data is coming here to split data. 70% is going here. 30% we have not connected yet. We'll come to it. And linear regression is coming to training model. Okay, so we'll go to train model now because it is still showing the red alert here. Right side, properties. You see that added columns. This is what we are going to select. What we are predicting, price. So the training model will work on price. We will type it by hand. We'll hit OK. The price. See, the red alert will disappear now. This is how it looked like before we edited the column, before we added price. And this is how it looks like now. If you do not see this, you have done something wrong. So you go back and correct it. Evaluate model. We'll test it now. For that, we will need evaluate means we are going to compare the price here, which is a number. For that, we will use something called score model, comparing scores. So we'll drag the score and we will drag the evaluate model both onto the canvas, both boxes. So this is how it is now. You see, red alert is there. It is incomplete. What I said, 30% of the data is used for testing. So this is the 30% data here. And we are going to connect it to score model here, because this is where we're going to test. This is 70% of the data. This is 30%. And you see, a bit confusing. Let me explain. 30% of the data connects to score model. It is going to compare scores. But compare with what? With 70% of the trained data here. So this will come here. Now score model will go to evaluate. It will just create a score and give it to evaluate model, which has its own intelligence for the comparison. It has some statistical intelligence built into it, the evaluate model and the score model, both of them. So this is how the complete picture looks like. So many arrows, but if you follow step by step, you have the reasoning correct. No matter what the interface changes, you will be able to get through it easily. Okay, now we go to the bottom part and run the experiment. It asks us to create a target again. I deleted the earlier compute targets, so I created a new one again. So we'll hit run. And as usual, there is no visual except the upper right corner, queued it is. So it will go to same queue, preparing compute and running. It took 45 minutes for me to run this experiment. Yeah, it is pretty much time consuming for a 25 kilobyte file, which is 0.025 megabyte. Well, it does take its time. Okay, once it is done, you can see all the green checks here. It means it is finished. All the boxes are green checks. Then we can right click on this dot here and click to visualize. See how it looks like, the score model. Let us see. So you see, I zoomed into this. How many columns are left? 58 rows and 26 columns. There were 256 rows if you remember, 226 or 56. This is 30% of them after the cleaning and everything. And you can see this here. This is the price original. This is what the model has predicted. The price should be according to the model. This is the actual price. So let us see. Actual price for the 30% of the data, if you see the first one here, 9639, but predicted price is almost $11,000. So ours is some $1,300 difference. For the second value, the original price is $6,377. It predicted 6069, almost $300 difference. It won't be 100% accurate. You will not find 100% accurate models. If somebody says I have done 100% accurate models, well, he has chosen the wrong models, or he has chosen wrong kind of processing. It could be 99%, but it's never 100%. It is called overfitting in machine learning terminology. Okay, same way we can go to evaluate model and right click it and visualize it. How does it look like? And you can see there are 5 values popping up on the screen. Now we do not need to be concerned. They are for the people who know statistics, but 2 values here are of most concern to us, for even a citizen data scientist. You need to understand them if you want to comprehend machine learning modeling. One is coefficient of determination, other one is mean absolute error. These 2 things you must understand. Now what are these? Coefficient of determination, it's a statistical metric indicating how well a model fits the data. So 0.87 means 87% accuracy of our prediction. In mathematics, it is also called R-squared value, just same thing it is. And mean absolute error is the average of the difference between the predicted value and the actual value. We have it as 1774, which means the price difference on an average between the predicted price of the car and the actual price of the car is around $1,774. So these are the 2 numbers you get, 87% accuracy with $1,700 of error. This here and there, you can say less or more will be the original price according to this number. Okay, we have done the experiment. Now this is very important step for any business. You have created the experiment, run the experiment, it has cost you money. So before it costs you more, you better clean up the resources. There are some very subtle things you have to notice here. It is a 4-step process. Remove the experiment, remove all the resources, remove the resource group, remove the resources from each blade. This is a cautionary recheck, which you should do, because I have done some 40 times run an experiment, maybe 50 times. Once something was not removed even after following all these 3 steps, one time, and it may cost you a lot of money. So let's go into remove the experiment first. So you go to home page, you will see list of experiment. You select all of them and then you hit at the bottom part this delete button. As soon as you hit delete, there will be pop-up from the bottom, which is going to tell you you are going to delete these two. And on the right side, you will see this check and the cross button. Till you hit this check, it will not go, it will not delete. So you have to select it and it will be deleted. So home page, the experiment is gone, not the resources yet. So we'll go to left pane, we click on the all resources blade, and you can see all resources here. And you see delete button is deactivated. So what you have to do is select this here, this box, and it will, you see, once you select box, everything else is selected. And on this right corner, this notification panel you go to, it will appear. Always go to notification panel if you don't see anything happening. Always do that. Let's zoom into that. So you see delete button is activated now. But how we are going to delete? Let's zoom into this right part. Delete button is deactivated here. You see, we have to confirm it. We have to type yes here. Otherwise it will not delete. So we type it here and you can see delete is activated. And once I hit delete, you can see executing delete command on 4 selected items. 20 minutes, 25 minutes it takes. Yes, you'll be charged for those 25 minutes because those resources still are existing unless they are totally gone. This will change to execute delete command on 4, but we have to check how many succeeded, how many failed. So 4 succeeded, 0 failed. We had 4 resources. We should go back to all resources blade and see there are no resources to display, right? Wrong. Not all the resources are gone. If you do this and you think you are done, it may show up as $300 extra in your bill next month. What are we missing? We are missing the resource group here on the blade. You go there and you can see here. And sometimes you may see more than one resource group which you have not created. It just pops up automatically. It happens. So you have to delete that also. So we click on this resource group. This is the resource group homepage. You can see October 18 RG. And you click on this delete resource group button. This you will see on the notification panel. I just went directly to it. You have to, you see delete button is deactivated. You have to type the resource group name here. Yes will not work writing yes. So October 18 RG I will type completely and you can see delete button will activate and you delete it. You go to notification panel and check it, what is going on. This will show up, deleting resource group. Takes around 15 to 17 minutes, sometimes 35 minutes. It depends on what I don't know. Once it is deleted, you will see, go back to resource groups. You should see this, no resource group to display. This should be there. As a cautionary check, you should check all these services, all these 6 of them. App services, SQL database, because whatever sample database you are using, that may be in SQL database, maybe in Cosmos DB here. Virtual machines, sometimes it creates automatically load balances it uses, storage accounts. Virtual networks means if you are running the experiment from your location to US region you have chosen to run the experiment, those will come under virtual networks behind. So make sure you check each and all of them, at least these 6. Otherwise, $300 or could be $3,000 show up in your bill, and there's nothing you can do about that. This is so even if a service is not running, even if you have removed all the resources, but resource group is there, which is actually not running anything, it will still cost you. You have to remember this. Okay, so we have provided few links for the information, and right now I'll give the control back to Rafael.
Thank you so much, Arnold. This was an excellent presentation. I really enjoyed it a lot, and we had a lot of activity in our audience. So for those of you guys who joined us later, this webinar, the recorded version of this webinar, It's going to be available within the next few working days, along with the slides. We are perfectly aware that it's quite a lot to swallow. However, we encourage you to, once the recording is available, to recreate the experiment that Arnold showed to you today. And it's actually very gratifying, especially if you are
Hello. Okay, looks like something has happened. Okay, is my connection gone or Raphael's connection gone? I don't know. Just, hey, looks like your connection is gone.